Hey guys, Nova Light here for the third installment of Gravitime Theory. We're going to do another Gadanken experiment today, and I'm going to show you how uh, gravity and time are actually both illusions of the same process. And the whole reason it's called Gravitime Theory is the merger of those two uh, things that physics calls forces. There's this elusive, difficult problem that they're having with gravity at really small scales where it doesn't, they're, they're having a really hard time detecting gravity uh, at low masses. And in particular, there's a huge problem where they're trying to quantify or create a gravity system that is compatible with quantum mechanics, and that's also not going well. The they have a bunch of particles that they've made up. There's several models, that are trying to uh, account for where that's gone and what's happening, and gravitime theory resolves that problem uh, because neither of them are actually real. I know it's even more ludicrous than saying time isn't real, but gravity is also not real. The uh, Obviously things in the universe have a tendency to clump together and stick together, and it's very obvious that objects with large mass pull on each other, and that even with a large enough mass, you can warp space itself. So I'm going to show how my model accounts for this and why I think it's the right answer. Um, to put it in simple terms, the speed of light is considered the speed limit of our universe. A photon can't travel faster than the speed of light. It only travels at the speed of light. But calling it the speed of light is actually kind of a misnomer. Light has no velocity. It it has no mass. So when they say the speed of light, what they really mean is that's the speed of causality. The universe cannot update itself any faster than that. Gravitational waves travel at this speed, photons travel at this speed, and uh, if you get close to that speed, your relative uh, amount of gravitime uh, goes up compared to an outside observer. So where is this emergent property coming if gravity is not real? Well, it's coming from the Higgs field. The Higgs field was confirmed by CERN at the Large Hadron Collider in 2012, and I remember even celebrating that discovery. The Higgs was a very really I would say the most important discovery to come out of the Large Hadron Collider, because it effectively completes our standard model. It was the last piece that we had yet to identify and catalog. And now that we have it, it still has, there's still a lot of problems around gravitation. We didn't we didn't get the solution to gravity, but we did verify that the Higgs boson and the Higgs field are there. In gravitime theory, the Higgs field and the Higgs boson are actually the communications layer to our universe. And if the speed of light is the speed of causality, then gravitime is the bandwidth of causality. So we can transfer information. The universe can update itself at the speed of light. But if too many particles are in the same place, they pull each other together. They fall together. They clump together in this collective runaway process, especially if there's lots of them, right? It's how solar systems and stars form. So in gravitime theory, actually let's dive into our third Gadanken experiment, and this will drive home how the Higgs field gives us the illusion of gravity. And I want you to just imagine yourself out in outer space again, and I want you to imagine two atoms of hydrogen just, moving in opposite directions uh, towards each other. So we've got two atoms of hydrogen, and they're going to get really close to each other as they pass, but only two atoms of hydrogen. The smallest atoms in our universe. And they're going to fly past each other. When they get within a certain distance of each other, the Higgs field, they both have a Higgs field. The Higgs field in each one of those atoms communicates. Now, it's not sharing a lot of information, but I would posit that it's just basically saying this is where I'm going. Velocity and direction, right? The 3 degrees of freedom that we have in our universe. It doesn't have any relation to the empty space around it. They don't have any relation to the empty space around it, just each other. So as they pass, just a little zip, not even a photon. It's a different communication layer. I haven't identified specifically whether it's a two-dimensional channel or something else, but the Higgs field specifically, this bridge of communication that's happening between these atoms of hydrogen is completely undetected. I want you to place just a ball of, like, for the sake of this example, we'll just say uh, 1,000,000 atoms of hydrogen. And they're all really close together. They don't have a lot of relative velocity, so we can kind of spin this around and look at it a little bit closer. And while those atoms are close enough to each other, the Higgs field is constantly sending these update channels. Every atom, every particle in our universe with a Higgs field, which is every atom at least, is sending these updates and the updates are being broadcast simultaneously by every particle with the Higgs field. And the radius of those updates is proportional to its mass and also the number of particles. So if we have one high mass particle, it's going to, in a large system, it's going to interact slightly differently than a group of small mass particles, right? And so to us, we just say, okay, well, that's gravity. There's more mass, so there's more weight. It pulls on everything around it more, which is true. But on a large scale, the number of connections is also important. So this ball of 1,000,000 hydrogen atoms, every single one of these atoms is sending update information within this radius. So you have 1,000,000 atoms all updating each other, all sharing this just basic information with each other through the Higgs field. Now, if these get close enough together, or if we get enough atoms in a small enough radius, all of that communication that's happening causes a traffic jam. There's a finite amount of information that the Higgs field can transmit without creating a reaction. However, once you cross that barrier, the Higgs field, the way it continues to communicate still, is it expands its local space, creates a bubble. And that bubble, that little divot that we call gravity, right? That little divot isn't actually uh, a hole. It's not a bowl. It's not anything. It is the fabric of space gets a little bulge in it because there's too much information being shared on the Higgs field. And so that little bulge in the center of this ball of hydrogen atoms causes all of the hydrogen atoms near that dimple to fall towards each other. And then what happens? It causes a chain reaction. As those hydrogens fall together, they get closer together, they share more information, that divot gets more compacted, and it causes more and more of that hydrogen to fall together. But it's not an inherent property of matter. It is a reaction of the fact that there is a certain amount of information that the Higgs field can share in a given area of space. And if it exceeds that amount, it creates a bulge so it can continue communicating. And by fact of relativity, now all of the hydrogen in the center of that has more gravitime than the hydrogen on the outside. So it's taking longer for that information transfer to happen. And that's why time and gravity are interlinked. We've proven that. We can show that. We've done atomic clock experiments. You can run an atomic clock up a mountain and it'll run a little bit faster. You can take an atomic clock up in an airplane and the velocity will cause it to run a little bit slower. And that's because that information can't update as quickly because its local gravitime is higher than its relative twin. This is why we don't see gravity on small scales. This is why we can't see gravity in quantum mechanics. Because gravity isn't there. The reactions that are occurring simply by fact of that matter existing next to each other and the Higgs field uh, causing them to communicate. So what is this? This seems kind of like an arbitrary, hair-splitting kind of argument, but it's very different from the way that we're actually explaining gravity now. We call gravity a force. And it's not a force. It's a result of matter uh, using the Higgs field just to update what it's doing. So in the universe, what we actually see is that very large bodies make very large divots. The stars make these incredibly huge, gigantic wells in the curvature of space. Our host star is making is updating so much information that it's holding that all of the planets in our solar system in their orbits. Now, those systems are actually multi-body systems, and every single large body in gravitime theory, when they get big enough, the Higgs field gets so overloaded that it starts to communicate those updates on a hierarchical structure. So the Higgs field can't update the entire solar system with every atom of hydrogen in the sun, but it can locally update itself. I also believe that this is what one of the things that contributes to the plasma phase transition is those the the local space is literally grinding against the it is the friction of our universe as it hits this bandwidth wall just constantly. And so large bodies like the sun, you can treat them as single objects with incredibly deep interaction radii. So the sun's interaction radius is all the way out to the Oort cloud. And it's holding, it has so much information. There's so many atoms in the sun that it's enough of a divot in space to even interact with the Oort cloud. So imagine a, a sphere around the sun, but it's a gradient, and it's a steep gradient. It's not a linear gradient. It's a curved gradient. And near the sun, it's strongest. And so if we take a two-body system and just say, okay, the planet Earth and the moon. The planet Earth has this amount of mass and this number of particles in this radius, and it's going to have this interaction radius on a cubed curve, and the moon has its own gravitime metric, and those two, all of the atoms in the moon aren't actually updating all of the atoms on the planet Earth. The two bodies are just updating each other in the Higgs field. So it's a super channel of information going between the two. There's a super channel coming off of the Earth, going to every other large body in the solar system. And we get the total gravitime interaction of every subsystem. And then you can even take the entire solar system as a single system, which also has a larger interaction radius than just the sun if it was by itself. There's more mass. There's more particles. And it's this hierarchical update that is also, you'll see in the next video, that's why the black holes are causing different behavior than we're expecting. So I hope that's not too counterintuitive. I hope you can see my perspective in explaining why gravity and time are both illusions of interactions on the Higgs field, and that gravitime is the bandwidth of our universe, and the speed of causality is the speed limit that an update can happen in our universe. Thank you so much for your time today. I hope you'll like and follow and subscribe and all that shit. I could really use your support and a signal boost on this. I need to get this in front of some established physicists so that I can really break this into the world of physics, because it needs to be there. I have the right answer.